Hello, my wonderful geometry students. Welcome back to the last half of Chapter 6. We're going to talk about 6.4. This is tests for rectangles. I don't know if you recognize, but Section 6.3 was tests for parallelograms. So it's going to feel similar. We've got some different properties, some different rules. But anytime I ask you, is this a rectangle, you're going to come to this table right here and you're going to say, yes, it is because this rule applies. So first of all, notice I've got myself an example rectangle up here, TSRU. I've got the two diagonals drawn in because the diagonals do make a difference. And our first property of rectangles is that the opposite sides are parallel. That's exactly identical, in case you didn't realize, to parallelograms. And I should have typed in both pairs of opposite sides are parallel, because it has to be both. In section 6.3, I underlined the and, it has to be both. So in this, we could say that side TU is parallel to side SR, and side TS is parallel to UR. And is important, remember. So similar, just a rectangle, so that's the same. So in other words, a rectangle could be a parallelogram, right? Because both pairs of opposite sides are parallel. We're going to look at those similarities. Another rule is opposite angles are congruent. And I should have typed in both pairs of opposite angles are congruent. So I could say that angle T has to be congruent to angle R. And angle U has to be congruent to angle S. So both pairs of opposite angles are congruent. Same as before. Before I went to both pairs of opposite angles are congruent, I forgot to ask about that coordinate plane question. You all know, because we did this in section 6.3, if I'm on a coordinate plane, an XY graph, and I'm looking for parallel, what do I need to use, or what do I need to calculate or count in order to determine parallel? Right, that would be slope. So if I'm asking you to show me that both pairs of opposite sides are parallel, you've got to find slope if we're working on a coordinate plane. The angles, again, like I said in 6.3, we don't do much with angles on coordinate planes because that's a different concept. That's a protractor. We'd have to actually measure them. Next rule, to determine if it is a rectangle, we would say that both pairs of opposite sides are congruent. And I should have typed in both. Both pairs of opposite sides are congruent. So in other words, TU has to be congruent to SR, and TS has to be congruent to UR. And both pairs. Now, I'm going kind of fast. I think I am. Maybe you're telling me I'm going slow, but it's because all of this feels very familiar. We've talked about this with our parallelograms already. So, next rule for rectangles is, this is a new one, the consecutive sides are supplementary. Consecutive sides are supplementary. Everybody remembers what supplementary is, right? It means they add up to how many degrees? Did I say sides? Consecutive angles are supplementary. So consecutive angles add up to 180 degrees. Remember, interior and exterior angles make a straight line. They add up to 180. It looks like a straight line, two angles put together. So if I took angle T and added angle R, I would have 180 degrees. Nope. If I took angle T and added its consecutive angle, angle S, I would have 180 degrees. Sorry about that. If I took, say, angle R plus angle S, any two angles next to each other have to equal 180 degrees. Now, I'm hoping in your mind right now you're thinking, duh, because if it's a rectangle, you know something, right? You know about the angles. And that's going to be in like 2 blocks down, so hold on to that duh for a moment. Do you need me to write out all 4 pairs of consecutive angles that are supplementary? You get the idea, right? T plus U is 180, S plus T is 180, U plus R is 180. All of those add up. Any consecutive, so not opposite, but side-by-side angles. Next rule for a rectangle is the diagonals bisect each other. We talked about this already. We talked about this in parallelograms. So one diagonal cuts the other diagonal in half. So in other words, this diagonal TR cuts the other diagonal SU into 2 congruent pieces. So we know these 2 guys are congruent to each other, and those 2 guys are congruent to each other. I got to take my writing off of there so I can see. So I could say that TQ is congruent to QR, the 2 pieces of the diagonal. And for the other diagonal, the 2 pieces, UQ has to be congruent to QS. It's an and. Both of those things must be true. The diagonals have to bisect each other. And let's see. This one is the duh moment. So when we're talking about the opposite angles are congruent, both pairs, or the consecutive angles are supplementary, if it's a rectangle, you know something already. You know that all 4 angles are right angles. All 4 right angles are right angles. I took my rectangle and put it down here. So angle T has to be 90 degrees, angle S, angle U, and angle R. Now, obviously then, opposite angles are congruent, right? T and R have to be congruent, and S and U have to be congruent. They're both right angles, 90 degrees. Also, supplementary angles, T plus S, both 90 plus 90 equals 180. So you might have already realized this, or maybe I should have said all 4 right angles are right angles way at the beginning. But there's a reason we spelled it out that way. I forgot to ask you one thing. Man, I'm getting ahead of myself. If we're talking about bisecting each other, just like we did in section 6.3, if the diagonals bisect each other and we went to a coordinate plane, how would you show that? You could show that TQ is congruent to QR using the distance formula and UQ is congruent to SQ, but that seems like a lot of work. What I would do is I would find the midpoint Q and make sure it's the same for both of those segments. They cut each other in half, so the halfway point has to be the same for both segments. All right, last but not least, in a rectangle, the diagonals are congruent. You don't have to write that green italic part. If the diagonals are congruent, then the figure is a rectangle. So not only do the diagonals bisect each other, but TR also has to be congruent to US. Therefore, if they cut each other in half, what do you know about all 4 of those parts? If this is congruent to this, and TQ and QR are congruent, but the whole segment US is the same length as the segment TR, I'm hoping that you're noticing right now that all 4 of those little chopped up pieces will be congruent to each other. That could come in handy later on. All right, let's do, I think a couple examples should be fine because this feels a lot like what we've been doing all along. There's a reason for that. We kind of group things together. So let's say in problem number 2, let's do 2. Let's skip 1. 1 is too easy. 1 is just the diagonals are congruent, right? It gives us segment US and segment RT. Well, US is congruent to RT. Too easy. Let's not do that one. Let's do number 2. In rectangle RSTU, the measure of angle STR, so this guy right here is equal to 8x plus 3. The measure of angle UTR, this guy right here, I'll put 2 marks, is equal to 16x minus 9. Find the measure of angle STR, so the upper one, and it is a rectangle. So, any thoughts on the matter? Rectangle is really a key word, right? What did we say in the last thing on our box, our table, our rules about, oh no, not the second to the last one, about all four of the angles that you already know about a rectangle, right? All four angles are 90 degrees. Therefore, this angle that we gave the two bits and pieces have to be equal to 90. So it kind of takes us back to that one chapter where the angles are either congruent or they add up to something. These two angles are complementary. They add up to 90 degrees. So I could say 16x minus 9 plus the 8x plus 3 has to be equal to 90 degrees. Let me combine some like terms here. I think that's going to be a 24x minus 6. I may need a calculator. Add 6. So if 24x is equal to 96, I believe when I divide, that's going to be a 4. I could be wrong, but I think that's right. Are we done with this problem? No, right? Because it asks for the measure of angle STR. Angle STR, which was equal to 8x plus 3. Angle STR equals 8x plus 3. We just found out that x was 4. So 8 times 4 plus another 3. What is that going to be? 32 plus 3. So angle STR is going to be equal to 35. End of problem. So there's some sneaky problems in there. It just feels a lot like those old ones where are they congruent or do they add up to something? So we can do that with segments and angles. So that's what these problems are going to feel like. So I'm going to just skip down to the coordinate plane one. So it says determine whether whether quadrilateral ABCD is a rectangle given each set of vertices. Justify your answer. Let's actually go to letter 6B. Same directions. So is this a rectangle? It's a yes or no question. Yes or no. And explain or justify or show me the work. Remember, it looks like a rectangle is not a good enough answer. So let's graph this guy. F is at negative 3, 0. G is at negative 2, 3. H is at 1, 2, 3, 4, 1, 2, 3, 4, 5. I should have this pre-graphed. J is at 3, 2. So here is my rectangle, or my quadrilateral, that I'm dealing with. Now, you are probably going to say immediately, is this a rectangle, yes or no? I'm hoping everybody's going to say no, right? Just looking at it, it's a no. So no, not a rectangle or circle, whatever. However, the explain part is the part that I want me to show. So I think the easiest way to explain or to show is to use slope. If you show that these slopes are parallel, we've got ourselves a first step. Then we have to go one more step. So let me write this down kind of, maybe you could write this in the 6A spot. So 2 steps to do this. You're going to start by finding the slopes and answering the question, are opposite slopes parallel? Because that's important, right? That was the very first thing I think that we said was that both pairs of opposite sides are parallel to each other. But once we know that, here's an example where I'm pretty sure that both pairs of opposite slopes are parallel. So if I found the slope of GF, the slope of FJ, the slope of JH, and the slope of GH, let's do that really quick so I can show you why we have to go one more step with this. So GF, rise over run. So to go from F to G, I go up 1, 2, 3, and over 1. So 3 over 1. F to J, I go up 1, 2, 1, 2, 3, 4, 5, 6. So up 2 over 6, so that's 1/3, right? For JH, so J to H, I go up 1, 2, 3, and right 1. And GH, I go up 1, 2, 1, 2, 3, 4, 5, 6. It looks like it's another 2 over 6. So I definitely have opposite slopes are parallel. But is it a rectangle? It's not, right? Because it doesn't look like a rectangle, because what does a rectangle have for all of its corners? It has perpendicular corners, 90-degree angles. So step 2, I'm going to say are the angles 90 degrees. So in order to do that, we are going to have to look at consecutive slopes. So we're going to say consecutive slopes. Remember perpendicular? That means they're going to be opposite reciprocals. Opposite reciprocals. I can't remember what chapter that was. Maybe it was chapter 3 or something that we did that. So in other words, I'm asking if GF has a slope of 3/1. I better write that in a different color. GF has a slope of 3/1, and FJ has a slope of 1/3 when I simplified it. Are these two numbers opposite reciprocals, opposite signs and flipped over fractions? Because if they are, then they're perpendicular. You probably can look and see this is not a right angle right here. Not right. 3/1 and 1/3 are reciprocals, but they are not opposite signs. So this is a parallelogram, but not a rectangle. So if you wanted to just say, determine if this is a rectangle, you could just say, no, it's not a rectangle because the consecutive sides are not perpendicular, or there are not right angles. Not right angles. And then you show me with your work what that looks like. So yes, I know these problems are a little bit busy, but hang in there. You can do this. If you graph them, you'll know the answer. You just got to figure out how to show me the work. So that is it from section 6.4, rectangles. Let me know if you've got any questions, and you've got this. No worries. Use that table to your advantage. I'll talk to you later. Bye.